The system model engineers are responsible of the design, modeling, and composition of the system architecture. They create a hardware or software component with concrete specifications and certain security requests. The SecFutur engineering approach supports the designing process, providing assistance to enhance the system model with security mechanisms. Therefore, the SecFutur Process Tool helps engineers when a system model has been created and the expert has performed a security analysis of it, collecting all the estimated security requirements. The process starts with a model, which is an excerpt of a set-top box architecture, describing some components. In our example, the system model engineer wants to secure all the data related with the class third-party app info. To accomplish this task, the expert accesses to the SecFutur security repository to import the DSMs that provide the necessary security knowledge to achieve the security requirement. The repository interface shows all the DSMs with the available security properties, but the system model engineer is interested only in those that provide security for stored data in a set-top box. Therefore, the expert uses a search feature to find a DSM containing set-top box secure data. The result list shows only the set-top box DSM that includes the secure data security property. We can check the description of the security property or several elements of the DSM. If the system model engineers validates the model, the next step is to import the artifact to the SPT environment. The DSM is automatically downloaded and activated. All the imported DSM can be seen in the active data view, and they are displayed in an intuitive way to review where they can be applied, the description of the elements, or how the security properties are composed. Now the system model engineer selects the element to protect, the third-party app info, and the SecFutur Process Tool shows in a contextual menu all the available security properties that can be included in the model, classified by domain of knowledge. In our case, the system model engineer selects the secure data under set-top box option. We accept to create all the derived properties, and the security data is automatically included in the model and attached to the target element to protect. All the added elements represent the security knowledge gathered in a DSM. The system model engineer can review a wide collection of data to understand the principles, considerations, and risks of the security property. There are many elements described in the model. For instance, threats like the data tampering and its corresponding attack interception of data. The security knowledge displays critical information to be considered in the implementation and development phase. The expert locates the abstract security requirement. This element has no meaning at all until the system model engineers define it. In our case, they establish this element as third-party app info secure data. When the system model engineers finish with the review of the security knowledge, they proceed with the evaluation of the solutions. This final stage starts in a security solution element attached to the security properties. In our example, the main security property is a secure data, and there is a secure data solution attached to it. This element contains a security pattern and the reference to the implementations. We can also review an XML visualization of the security pattern if we click the View Pattern option in the contextual menu. This information is interesting for the security model expert because it describes how the implementation has been created. After the system model engineer checks the security pattern, It's time to deploy the implementation in the system model. Located in the secure data solution, the security pattern provides all the available implementations. In our case, we select to add secure storage. Then, the SecFutur Process Tool starts the importing phase of all the required elements. First of all, it retrieves and includes the solution template from the repository. This template defines all the validation and verification rules to be fulfilled by the implementations. The package of rules contains all the constraints and tests for the model checking. Following, the implementation model is imported from the repository and also added to the system model. This artifact is a security building block, capable to achieve the security property and to provide the concrete realization of the solution. When the security building block has been imported, the SecFutur Process Tool is ready to start the integration of the implementation in a system model. The system model engineer receives a message about the security building block. In our case, the user gets some information about the solution and the implementation. But the SecFutur Process Tool also inquires to the system model engineers if they prefer an automatic deployment of the implementation, or on the opposite, if they want to select all the required elements manually. When the expert chooses the manual process, the SecFutur Process Tool will ask for all the elements that must be connected or integrated in the system model. The first element to connect is a SBB Secure Storage Solution interface. We can select the desired element to be associated with the interface, or we can also let the SecFutur Process Tool to create the element, and the modeler will decide later its functionality in a system model. The system model engineer decides to select the element and locates the App Store client owner of the third-party app info. The expert wants that any access or use of the interface will be managed by the class. The expert wants that this class manages any use of the interface. Now the user has to decide about the key manager element. The architecture does not contain any entity acting as a secure container for keys. Therefore, the system model engineers decide to create the element. When the process has finished, the SecFutur Process Tool shows the final report, displaying all the changes done in a model and how the different components have been connected or created. At this moment, the system model contains the security enhancements of the secure data property and the implementation fulfilling the security requirement. The system model engineer can hide the abstract security knowledge, obtaining a clearer view of the architecture. The model is ready to the development phase, where users can take advantage of the code generation support of Magic Draw, or they can export the model to any other standard format.